Now let's talk about question number 62. Now let's talk about question number 62, which is one of the important question and a very good numerical from energy. And this question have been taken in the class also. Question number 62. So it's a very simple question, not tough, but just a key hint. A small hydropower station based on the conversion of kinetic energy of a river water generate power. If the flow of the water is 10 cubic meter per second and the speed of the water is 3 meter per second, what is the maximum power the station can generate, assuming the efficiency of the power station to be 0.6. So keep that in mind what they have given to you. They have provided you with the flow of the water, which is cubic meter per second or cubic. They have given the speed of that water. They have given the efficiency. Right now, let's see some of the detailed briefing about it, that how we can deal this question. So okay, so now let's see that how we can approach this question. So first of all, you have to see that how we can come about with the formula when we have calculate the power and we have been given like effective head and flow rate. So the power supplied by a plant to the number of watts, the rate at which delivery of energy is taking place, the number of joules per second, that is basically what the hydropower plant, this is obviously depend on the volume of the flow rate. So these things it depends upon volume, flow rate, moving water, and the number of cubic meter per second passing through the plant, usually represented by Q, which we said flow rate. Then we have acceleration due to gravity, and H, which is the effective head of the river. So these are the quantities on which the power generated depends. And you can see here, this is the very simple formula which have been given. So power in watt is equal to 1000 into Q, where you can see Q is flow or flow rate, you can say. So Q is cubic meter of the water passing through the plant per second. Then G, we have acceleration due to gravity, and H is basically effective head. As I told you, H is basically effective head. H is basically effective head, which is being mentioned here in this formula. Like you can see here, we have Q, which is flow rate, we have G, acceleration due to gravity, and we have H, which is head. Then if you have been given the efficiency, this formula on the right hand side will be multiplied with the efficiency as shown here. Like if some plant is 40%, some is 50%, some is 60%. So an additional quantity, which is efficiency, right? Efficiency will be multiplied, which is denoted by eta. You can see here. Rest of the formula will remain same. And this is H is effective head, right? So this is the formula which we have to use in order to calculate that how we can calculate power. Okay. So this is the formula that effective head we have to take. So you can see here the power can be calculated very easily. That power is equal to 1000 into Q into G into H into eta. Keeping in mind the things which have been given here, we don't have effective head in the given equation, right? And if I go by a general diagram, let us suppose I am storing here the water. Let us suppose my quantity is being stored here. And then I have a pathway like this. Then I have a pathway like this. Right. And then I'm going down with this thing. Okay. And if you see this water is being going across this, and from here to here, this water, just a minute. This water is moving from here to here. And this is taking this path. And let us assume this is the effective height H, which we have to calculate because we have not been given the effective height. So we can generally simply apply the simple equation which we have studied in 11th and 12th class in laws of motion, right? And there we have v square minus u square is equal to 2gh. Using that equation, we can calculate the head like this. V square minus U square is equal to 2GH. You can correlate with that here. U square will become 0, which is the initial velocity, right? So this formula will be reduced to V square is equal to 2GH, and H would be equal to under root of, sorry, H would be equal to V square by 2G. The value of V has been given in the question. The value of V has been given in the question, which is 3 meter per second. So we have been 3 meter per second. And G, you know, all of you know, we can take approximately 10 for the easiness of the calculation. Like G we can take approximately 9.8 meter per second square or 10. It depends upon us if we want to take it the simplification of calculation. But unless and until we have not been asked, we should take 9.8. So this is the basic theme of this question, and then you can see easily here we have applied the same formula. P is equal to 1000 into Q into G into H into eta, and V we have calculated. So H we can calculate from here. So this will become P 1000 into Q into V square by 2 into eta, and the values have been given like you know, Q is 10 meter cubic per second, V is 3 meter per second. Then eta is 60%. So 60% efficiency is given. So eta is 60%. So 60% means it will become 0.6, right? So all the values, if you put up in the equation, Q is 10, V square will be 9, 2, and 0.6. And you can simply solve it. And this comes out to be 27,000 watt, which can further be converted into kilowatt, As you can see here, this comes out to be 27,000 watt, which can further be converted into kilowatt. So the final answer which comes out to be for power is 27 kilowatt, which is the correct answer. The only trick here is how you calculate the effective head. Is it clear to everyone? Anyone having any doubt in this? Quickly respond करिए सारे के सारे, जल्दी से फटाफट, quickly. Anyone having any doubt in this? So you can see here we have been given one of the choice 27 kilowatt, which is choice number 2. So this is the correct answer, and this was covered very well by Ali sir in the class, and we have given enough amount of detail in the solution also. Is it clear to everyone? Anyone having any doubt in this question? कोई भी आपको doubt होता है, please inform us, because we are here to clarify all the technicalities that how you have to look the question. After reading the theory, what should be the approach? What should be the approach to solve a question after looking into the theory? So that's why we are giving so much of emphasis on each and every question. So now let's move to the next question, which is question number 63. Which is question number 63. Which is question number 63.